Welcome back to the runtime error. In the previous part, we saw the deletion part of the linked list. Now we will be discussing one of the beautiful question from the linked list which is on the Leetcode. So what does question says that? Our question says that they have given the head of the linked list, that will be the head of our first node. What we need to return is we need to return the middle element, that is 3. As we can see here is there are the 5 nodes and the middle part is 3. And they also says that if there are two middle nodes, return the second node. Means, say for example here it was 6, then these are my two middle nodes. Then what I need to do is I need to return my second node, that is a 4. I hope so you understand the meaning of question. Since there are the odd number of nodes, so middle contains only the single element. Now say for example here we got 6. Now my middle elements are of 2, right? 3 and 4. Now we have to return what they have told, that we have to return the second middle, that is 4. I hope so you understand the meaning of question. Now let's try to implement this. We will try to apply on a given example. So as I told you that first of all has to go with the brute force solution. So what solution comes in our mind when you look at this question? Can I say we can simply take all the elements inside my array and I can simply find the middle of it. Say for example I have took these elements in my array as 1, 2, 3, 4 and 5. And if I do the indexing will be 0, 1, 2, 3 and 4. Now if I ask you what is the size of my array, my size of my array is 5 and I need to find the middle of it. And if I do divide by 2 is equals to 2.5, and we will know that we take integer value which is of 2 and we need to return the element present at the second index, that is 3. So 3 will be our middle element. But can't we say that this is useless extra space? Can we do it something better than this without using extra space? Now as I told you, I have created one shot in that I have told you some of the techniques that you need to master so that you can have a good programming knowledge. And in that also I talked about one concept called as fast and slow pointer. So that is the concept we will be using in the linked list. Do remember, this is the most useful technique for the linked list. Now let's check how it works. Say for example I'm taking example once again. We got 1, we got 2, we got 3, 4 and 5. So these are my 5 elements and my head is pointing to my first node as usual, that is to this, right? Say for example its address is 10, so here will be 10. Now what I need to do is I need to find this element. We know that apart from traversing technique we can't do anything with the single linked list. Now the question is, can we do it something modification in my traversal technique? Can I do some modification? In a deletion part we saw that we need a 2 pointer, right? Just to make sure that I will able to come at the second last node, that is over here. In a similar fashion, are we able to do something in that way? Say for example I have the pointer 1, I have the pointer 2. Can I able to get that one pointer is present at my last and my second pointer is pointing at this position, so that I can get the element present at my middle position? Let's check. Say for example I have a fast, I have slow. As usual I have talked about this in deletion part. Now what I will do is I will take this fast 2 position ahead, that is from this and here, right? From this to this. And at the same time I will take a slow 1 position ahead, so that can I say when my fast comes here my slow comes here, my fast comes here my slow comes here. So can I return simply my slow so that I can get the middle element? I hope so what I'm trying to say. Say for example I have my fast, I have slow. Okay, my fast comes here and my slow comes over here. Now my fast goes at the last and my slow comes over here. Is it right? My slow will come over here. Now my fast is pointing my last node and my slow pointer is pointing to the exact position where I wanted to point, right? Because this is the middle element which I was looking for. This is the middle element which I was looking for. So I hope you understand what I'm trying to say. So let's implement it. Say for example, I got a pointer called as a fast, which is pointing to the head, and I also got a slow, which is also pointing to the head, right? So both are pointing at this position. Now what I will do is I will simply run a loop. Say for example, while, now I'm not writing any condition. Let's check what condition we need to write. So what I'm trying to say is I need to simply take fast equals to fast of next, which means my fast come from this position to this position. But the point is I need to take the fast to this position. Then can I say still I want the next? What does it mean is say for example, I have the node 1, I have the node 2, I have the node 3. Say for example, their address is 7, 20, 30 and this is null, this is 20, this is 30, right? Now my fast is pointing at this position. What I said is fast of next. So this is the fast of next is 20, which means this is this position, right? And again I'm using the next, which means the next of this, which means this position. I hope so you got me. Fast of next, currently fast is pointing to this node. Then I'm saying fast of next, that is at 20, which means I am at here now. Now again I'm saying this is next, which means next of this node, that is 30, and finally I will be present at my last node. I hope so you got me, right? So this is the way we tried it, and we know that we need to take slow as usual one step ahead, right? As usual one step ahead. So this is what we need to do is. Now the question is, what is the condition that we need to write? Because at the end we need to stop over here. Can I say it might be possible that sometimes my fast can go outside my linked list and sometimes my fast may present at my last node of my linked list. So I need to use both the condition. That is my fast is not null. Right? And also I need to take care that and then my fast of next is also not null, right? What does it mean is, say for example, right now I'm present over here, so I don't need to traverse again in the field again, because if I move my pointer from this position, my slow pointer will also move, so I need to stop at this position. Now suppose if in case I don't have this node, I don't have the last node. Now what will happen? We will check, right? This is my fast and this is my slow. Fast is not null, the condition gets true. Fast of next is not null, yes, it contains a particular node. So what I will do is I will simply take my fast to the 2 steps ahead as I shown you. So my fast will be pointing over here, and as usual my slow will come to the next position, that is over here. Now again, fast is not null, yes, condition gets true. Fast of next is also not null, yes, because it contains address of next node. So simply what will happen, my fast will come at this location, that is next of next. The next of this node is null, so my fast will be pointing to the null, right? And as usual my slow will come at this position. This is the reason why I write one extra condition, that is fast is not equals to null, because as we can see that the fast is pointing to the null. This is the reason why we write this one extra condition. Now simply what we need to do is we need to simply return slow. So this is the code which we were looking for in order to find the middle element of my linked list. Now what will be time complexity? For sure the time complexity will be big of n by 2, since we are taking a position 2 steps ahead, so it will simply divide it into half, but it approximately turns out to be big of n. So I hope you understand the explanation part of my finding the middle element of my linked list. Now we will check how to write the code on the Leetcode. So this will be the code which we will be writing on the Leetcode. So what I have did over here is head of next is equal to null, which means my linked list single contains a single node, so I don't need to find middle element of that list, because that single node is itself a middle element. And or what does this condition says, that my linked list is empty, and since my linked list is empty, do I need to find any middle element? No, so I need to simply return the head. Now as I told you that we require two pointer, one is called as a fast and second one is called as a slow. So we declare that both are pointing to the head, that is the first node. So this will be the fast and this will be my slow, right? Again I have checked in this, that is fast is my not null and fast up next is also the not null. So we have checked, is my fast is null? No. Is my fast up next is equal to null? No, because it contains the address of next element. Therefore my fast will be shifted from first node to the third node, that is it will come over here. And as usual my slow will be shifted to the next location, that is at this position. Again we will come to the loop, that is fast is my not null, fast up next is also not null since it holds the address of the next node. So simply the fast will be shifted to 2 steps ahead. What does it 2 steps ahead means? Fast up next I will come over here, its next means null, hence my fast will be pointing at null. So my fast will be pointing at null, and as usual my slow will come 1 position ahead. Now again I will come at loop, again I will come at this here loop. Is my fast is equal to not null? No, my fast is equal to null, and this condition gets false, and simply what I do is I simply return slow, and this will be my middle element. As I told you in the question, what they have said is if there are the two middle elements, we need to return the second one. So we return the 6. I hope you understand this question clearly. If you really like the way I'm teaching you, do subscribe the channel. Till then, have a happy coding.